the Security Cookbook session. Today, I'm talking, and that's me, Foxborough, Christoph Wollner, the Foxborough.net and web developer. I've been an international speaker for quite some time, even though you wouldn't tell from my performance today. I've been a former contributing editor for Foxborough Advisor, published many articles and many magazines, have been Microsoft MVP, and I also co-own a company. So if you need Foxborough experts in Europe, you have just found them. But let's go to the session. So today we are talking about security-related code, and there are actually not a lot of slides in this session. So we show code. Let's switch to Foxborough. This is a mix of all kinds of different things that I've covered in different sessions. And I've also given a version of this session before, but as a security, there's always something new in every time I give this presentation. So let's start with protecting code. We all know that Foxborough code is compiled into tokens and can be decompiled using Refox or other tools. So one of the things you can use to mitigate this risk is using something like obfuscation. So let's look at this code. This code is calculating an amount, applying a rebate and the value-added tax or sales tax for the United States. And it's highly sensitive code. Nobody has ever written anything like that before. So you don't want anyone to be able to see this. So let's look at what Refox would show with this code. So on the right side, you see the PRG file. And if I navigate to the FXP file, you see it now looks completely different. Not really readable. How did I do that? What I did is I created a header file, and every variable, I created another name that is, even if it looks strange, is a valid variable name in Visual Foxborough. So when you compile the PRG file, Foxborough is replacing the actual variables with these cryptic names, which are hard to read and hard to decipher. The only drawback, or the one drawback, is that this is also the variable name you get into error messages and in log files. So you want to make sure that you keep this header file around so that you can reverse the obfuscation. So how do I generate these names? I don't come up with them. I just generate them automatically. So a valid name in Foxborough starts with either an alpha character or an underscore, and can be followed by an alphanumeric value, underscore, or digit. So we generate a string that has a random length between 20 and 64 characters. It starts with either a letter or an underscore, and every other character is either a letter, an underscore, or a digit. In order to generate a random character, we just generate an arbitrary ASCII number and then check if it falls into the range. And if it does, we return. Otherwise, we keep repeating until we get a valid character. So very simple code. The result looks like something like this. So one of the new things that you have to keep in mind these days is AI. So if you look at this program, and want to understand what it does, well, previously you would have to do it yourself. But now what you can do is you prompt turn the following VFP code into readable VFP code, and then just paste this gibberish Foxborough code into ChatGPT or whatever AI you prefer. And I did it, and the result is this. So it does look a lot nicer than the obfuscated code. It did get wrong one thing. The 5 used to be the rebate and the 19 used to be the tax. It inversed this probably because in the United States, you get a lot of discount and pay little tax, versus in other countries where you pay a lot of tax and get a little discount. But it did figure out that is something with price calculation. It did figure out that one must be the tax and one must be the discount. So it's actually pretty scary. So you have to make sure that whatever you do in security, feed it into an AI and see what it figures out, because it might figure out more than you imagine. So, any questions so far? Otherwise, I'll just continue.
Nope, no questions.
So if we talk about passwords, basically, whenever you encrypt something, there are two factors that are important for encryption. One is the algorithm, what kind of encryption are you using? And one is the password. Even if you have the strongest existing encryption algorithm that exists, but use a password like 1234, it's not really safe. Everything you can attack with brute force is not safe. So you can never get safer than the password you're using. Passwords have become less important in many applications. In Foxborough applications, they are still important, because most of the Foxborough applications I have seen, if they have a login screen, they still have a login screen using a password, or they use the Windows user. But I haven't seen a lot of Foxborough applications using alternative logging or authentication mechanism. So one of the factors in establishing how strong a password is the number of bits. And the number of bits in the password depends on the length of the password and the characters you could have been chosen from. So not the characters you actually use, but the numbers that were available, which for most people is what's on their keyboard. This function returns the length. So if I have a password that has 6 characters and it's using uppercase and lowercase characters, no umlauts, and all 10 digits, what I actually have is a bit strength of 35 bits, which is just over 4 bytes or 4 characters instead of 6 characters. You can also combine this to get an evaluation of password strengths, because you really don't want to have users have a password that is X or something else, or have password that they just add 1, 2, 3, 4 at the end. So let's figure out how we can determine the password strengths. We return a numerical value, and the value should be larger than 0. The higher, the better. Anything below 0 or 0 or below should not be accepted at all. We start with a value of -11, which is -3 for every one of the 4 compounds of a password: uppercase characters, lowercase characters, digits, and special characters. In this case, I'm checking for computer name and username. You don't want to use those in a password. You could also check here against a dictionary of common names, because you don't want to have a password that is secret or invalid, even though it's really helpful if the computer says your password is invalid and it's invalid, so you can just type it in. It's not secure. And then next, we go through all these different groups and look for every character in the password that's being passed, get the password, and check whether it's an uppercase alphanumeric, a lowercase alphanumeric, a digit, or something else. And then we add the strengths based on the existing strengths, and then we add 3, for instance, for the uppercase, and then we also add based on the length. So what we get is, for a password like has only digits and is 4 digits long, we get a value of -10, and which says don't use that. If we use uppercase, lowercase, special characters, and digits, what we get is at 1, which means it's basically the minimum password you should accept. Everything longer would be much better than that. What this doesn't show is that these days passwords are not as used as much in other environments. So usually you would use a second factor like TOTP to send users some sort of message to a mobile device, a second factor that they have to enter. Commonly, we are moving to passkeys. Passkeys do not really work in a desktop application because in a desktop application, the instance where you enter data and the instance that is checking data is on the same machine and in control of the user. Passkeys work by using certificates or by using public-private keys more precisely. And when you create a passkey on the client side, you generate a private and a public key and give the public key to the server. So the next time you communicate with the server is sending you data encrypted in the public key, using the public key, and you have to decrypt it and do something with the data and send that result back in order to prove that you own the private certificate. That only works or does only make sense if the server is somewhere else, if it's a web server, for instance, or if you have an application server. But it's not useful if you have a user table on your computer, on the computer, and the code for validating the password is within the application. Passwords has also become more complicated depending on what kind of environment you're running in. In small mom and pop shops, which a lot of Foxborough applications are targeting, there's no IT department. They don't have complex domain single sign-on architectures set up. They don't use RSA token. But if you come to enterprise businesses, then you see a lot of single sign-on technology. You see tokens. You see the use of Microsoft Hello or of fingerprint readers, camera detection, face detection, and all of that. So passwords are still useful, but are used less. Okay. Let's move on to logging in. One of the things is what you sometimes want to do is you want to make sure that the user you don't want to implement the password checking yourself. You want to rely on whatever the domain has available. So you want to prompt the user for their Windows password instead of a password in your application. So you need a way to find out if the username that's been entered and the password are valid in the context of Windows. There's actually a way to do this. You can authenticate a user against a domain and a username with a password using the logon user API function. So in this case, you pass in a username, a domain. You have to separate those. You cannot use domain /username or user@domain. You have to send both separately. And you send the password that the user entered. And then you call the logon user function. And if the credentials are valid and the user has the ability to log on, then you get you get a user handler and the user is valid. If you get a value of 0, the user is invalid. So this can be used to check if the user knows the Windows account. So on this machine, I have a test user. I'm going to disable that one after the session, so you don't have to write down the password. It's not 1, 2, 3, 4. So if I execute this one, it should return false. because the password is a really great one. It's the same as the username test. So if I execute this one, I now get true because the username is the password was passed correctly. What you should be aware of is that this is based on the technology of back then in the before times, basically. So it's based on Windows 2000, Windows NT login mechanisms where we had usernames and a domain controller and passwords. ClickUser does not show a dialog. So if the system is configured in a way that it needs to have some smart card, that it has to have another token instead of username and password, then this method won't work. It will only work if the user can actually log in using a username and a password. If you have one of those modern Windows machines and you use the default setting, your username is actually an Azure AD user. So you would use Azure AD / your username, or in this case, Azure AD as the domain, and then your Microsoft login password as the password. In one case where this is actually useful is if you have a technical user for your application. So if you are not running the application as the user that launched it, but as a different user. That's helpful because one of the problems we see in Foxpo applications is that a Foxpo application has write access to the tables, to any table it needs. And the user has access because the application is running at the user account. So everything the application can do to a table, the user can do to a table. In some cases, you don't want that. You want to make sure that the only way a user can access tables is through the application. And one way would be to run your application as a different user. And that user is the only user that has access to that application. The way you do this in Windows is called impersonation. This code is based on an idea from Alf Bormann. In order for this to work, the current user has to have the network logon right. If the user cannot log on a network, then this code will fail. And until Windows 2000, which nobody's using anymore, you also needed the TCP privilege, which means act as part of the operating system, so nobody had it. So what I'm going to do here is I'm logging on as the test user. And then I'm using the impersonate logged on user API. It's an API function in Windows, which changes the user that the process is currently running under to the user that has been passed, or to the handler. After that call here, the application is running as a different user. I'm printing sys0, which displays the current user before, and then I'm impersonating, printing sys0, and then I'm using refer to self, which means go back to the original logon which run the application, and I'm printing sys0 again. So let's run this, and you see I'm currently the presentation user. Then I'm switched to the test user, and then back to the presentation user. So I'm actually running as a different user for Windows. It's not the same user, and in between these lines, I have every permission that the test user has. Logon user requires that you pass a password. And you don't want to store the password directly in a variable in code or hard-coded like I did in the sample, because that means that it's available either in source code or by analyzing the exe, doing statistical analysis, or simply by finding it in some error log or where you have a memory dump. So one way is, I'm calling, in this case, the API again, is to use a function. So I'm not storing the password in any Foxpro variable at all. I'm just using return values. I'm passing it directly. So the next recipient of that password will be the API and not Foxpro. It's never in any Foxpro variable. I go through this step by step, and that didn't stick last time. Just one moment. And your job is to figure out the password. You can see all the variables on the right and the source code on the left. And I go very slowly through this code. You look at the values, you calculate everything, you look at the expressions, and then you try to figure out what the password is. Very slowly, so you can follow along, do the calculation yourself, see all the expressions, and we're done. So we called the log_on function. The password was incorrect. Actually, the user doesn't even exist on my machine. So did you get it? Did you get it right? Let's see. Who had this result? I guess not that many. So one of the things that this code does is, if you put a password in code, there are ways to figure out that part of an exe is a password or not. And if you have memory variable, it's easy to get it. But if you put code in there, code looks indistinguishable from other code that is doing business things. Code that returns a password is not different from code that does anything else. So it's not really, unless you call it get password, it's not really easy to figure out that this is the code that returns a password. Obviously, it's hard-coded. You can enhance it by, for instance, using pictures embedded in your application and then using part of that picture using file-to-string and substring to get some other hard-to-detect parts. This code is also quite difficult for a lot of analysis because it's using function calls that seem to be dynamic, like sys9, which returns the serial number, which used to be different for every Foxpro instance when we had the old Foxpro and the distribution kit, but it's been constant ever since. It's also using things like sys2015, which returns a different value every single time, except that this expression over here says that it wants to have the 10th characters from the right, which is always the underscore, because this 2015 always starts with an underscore. Also, the menu names, just 2013, they always start with _m. So the second character of this string is always an m, so this value is always 2. And there are others that basically return 0, or sys0 has 3 components: the username, a hashtag, and the computer name. And the second word is always the hashtag, so that's a constant value. This space obviously is different every time you run the application, but scale mode P16 returns 2. Any hex number starts with x0, so this expression is always x0. So it's by using certain patterns in functions, you can kind of fool even AI, and I tried that. So this is what Perplexity made of this. It did analyze everything, but it figured out that some of things are dynamic. Some of things are dynamic, and it just picked some random string instead of the actual string that sys2015 would have. So it came up with this password, which is obviously completely wrong. So it's actually some protection against AI as well. Any questions?
There's one question actually going back to the obfuscation example. Can you make it AI proof?
That's harder to do. It depends on how well the AI is being able to figure out what code means. So the longer your code is, the more code you have, the harder it is for AI to figure out what part is doing what, because it can't execute all of that. It can't follow the flow, especially if you have configuration files that define how things are combined. It's becoming, at some point, it's becoming impossible for AI to follow. But it's definitely making it easier. It's in easy cases like the one I shown, it's already there. In other cases, it will take a long time to do statistical analysis on the code, and that's not what a large language model can do today. So for complex code, it's still AI proof. For smaller things, it's not. In this case, the code is using an expression that is very common, which is adding a percentage. So that's commonly used in certain types of applications, so AI can figure this out. And also, I have shown the sample before, so maybe there's somewhere some code that has been used for training AI. So you never know. But it's harder to do. It's possible, but it's harder to do, and it's a moving target. At some point, AI gets more intelligent or is able to solve more complex problems, and then you have to improve this again.
That's it for questions.
Okay. So now let's go to encryption. There are several ways that we can use encryption in Foxborough, and several problems with that. So let's look at the way that Foxborough was, or that the library that Foxborough shipped, the _script API, and use it to encrypt data. So we instantiate _script API, which is in the Foxborough Foundation classes. It's part of Foxborough, and it has an encrypt session block string method that you pass in data, a password, and you get back encrypted data. Very simple to use. I have hello world encrypted and run it. And you notice one thing. I passed in a smaller amount of data and I got back 16 bytes. Before we go to that, let's see if we can decrypt these 16 bytes. Decrypting is happening the same way, except that instead of encrypt session block string, we use decrypt session block string. And we pass in the encrypted data and we get back the unencrypted data. So in this case, we just encrypt and decrypt in one step. And we should get back the same we passed in initially, which is hello world. And as you can see, hello world is 11 characters and the encrypted string is 16 characters. That's because it's a block cipher. A block cipher always encrypts a block of data. So if you pass in, the default block cipher is using 16 bytes or 128 bits. So it's encrypting 128 bits at a time. It cannot just encrypt a couple of bytes and return a couple of bytes. It always returns a multiple of the block length, which is a multiple of 16 characters in this case. There are other ciphers called stream ciphers that make this easier because they generate an endless stream, an infinite stream of encryption passwords, basically, and combine this with the data and can produce any length of encrypted data. But they have a problem. So what we do is we have two strings and we have a password. They all have the same length in our example. And then we encrypt the first string and we encrypt the second string. So we have two encrypted versions. Next, we print the string, the original string, the encrypted version, and the encrypted version of the second string, but we don't print the second string. So we assume we know this one and we know this one. We also have found this one in the table or in the database, And now we want to have the plain text for that. So the problem is that the way a stream cipher is working is the hard work is doing the stream of data that is used for encryption. The actual encryption is just an XOR operation. So it's just using the stream that is generated, the plain text XORs both, and the result is the encrypted string. XOR is reversible. That makes it easy. That's a symmetric cipher. If I XOR the encrypted one with the password, I get back the plain text. So I can use the same stream for encrypting and decrypting just by applying it to whatever I get in. The problem is if I use the encrypted and the first encrypted one and XOR it with the second encrypted one, what I get back is the password stream. So in this case, let's close. Let's start again. Let's start this code. So here we have the plain text, the first plain text. This is the encrypted first plain text, and that is the unknown encrypted second text. And now we are going to XOR all these three together. We just XOR this, with this, and then the second character, this, and this. And the result is the original plain text too. So the one thing you have to keep in mind for every time you use a stream cipher is you can only use a password once. You have to use a different password every time you encrypt data. Otherwise, if somebody knows their password and the encrypted text and the plain text, they can actually figure out any other text up to the length of their own password, or up to the length of their own plain text that they know. So if you would encrypt a password in a user table, one would only have to create a very long password to get the maximum length and then use that to XOR the data in your table to get the password of everyone else. So that's one reason why you don't want to store encrypted passwords ever. You often have the need to store something protected securely on the user's computer, and you don't want anyone else to have access to it. And Windows actually has a way to do this. Windows holds an encryption key in protected memory that is specific to the user. It's only stored or only available when the user has logged on, and it's stored in a protected place for the user or in the domain controller for if you are part of a domain. So basically, only the user can ever decrypt this. This is what's being used for encrypting files. And that's why if you change your password outside of being logged on, you cannot decrypt your files anymore because this secret is being destroyed. In order to save data protected that only the current logged on user can access it at all, is you put this data in a blob structure. For the blob structure, we have to have an address. So we need to use heap alloc and get process heap to allocate memory on the VisualFox Pro heap. The structure is very simple. The first 4 bytes are the length of the data that we store. The next 4 bytes are the address of the data. The address is the address we receive from the heap plus 8 bytes because we have 4 bytes here and 4 bytes there. And then we have the data. You can also add some entropy. Entropy is some data that you want to add that is specific to your application so that even another application that is running with the same user cannot access your data. This can be something that's embedded in your application. It can be that it's dynamically generated for the user and stored somewhere. So it's kind of an extra password beyond the user's password for Windows. And then the result is stored in a block of the same structure. Then you call crypt protect data in order to protect this data. It returns a huge block that you can put somewhere, and it can only be decrypted by the user. So it's not stored in Windows somewhere in a hidden place. You get back this data, you can put it in a database, but it's impossible to decrypt unless you are logged on as that user. And you have to do some cleanup and then return the encrypted data. So let's look what this data looks like. So we have the data, hello, 5 bytes, and we use my app as the extra entropy, extra secret. And we execute this, and you see, you get a pretty large block because Windows is maintaining all kind of extra information about the length, the algorithm that have been used, and all kind of other data that's internal to Windows. So this would be the data you can store somewhere, and it can only be read on the user's machine using unprotected data, which looks remarkably similar to the protect data, except that in the end, we call crypt unprotected data, and we pass in the encrypted data and receive back the decrypted data. So again, we pass in hello to protect data, and then we pass the same thing to unprotected data. And when we execute this, we get back hello. If you pass in something that's incorrect, you don't get wrong data back. You don't get any data back. So let's do this. It's just returning an empty string because Windows is recognizing that the data doesn't match based on this extra data that we've seen, and it will not return any data. It will not give you wrong data. It always gives you correct data or no data at all, never any incorrect data. If you can't store a password, what you want to store instead is a hash value. So a hash is a function that takes arbitrary amounts of data and converts it into a fixed amount of data that is not reversible. So if you have a hash value, you just can't know what the original value was. Getting a hash value using the CryptoAPI is a little bit more difficult because we need to call a function that has a hidden method, or we need to call a hidden method. So I'm using a crypt VCX. The only difference from the one that ships with Visual Fox Pro is that I unhid one of the methods. We can look at this code. This is generating a short hash. So we call the crypt create hash, and then we add the data, and then we say what hash size we want, and there's a lot of code. In the end, what we get back is a binary value based on the length of the hash algorithm. So this is data in binary. You probably don't see hashes this way. They are more commonly shown as hex values. So that's the same thing. It's a 128-bit or 16-byte hash value. So it's using show 128, not very secure anymore these days. While a lot of old FoxPro code is using CryptoAPI, and it's one of the libraries that shipped with FoxPro, Microsoft has, for a long time ago, discouraged users to use the old CryptoAPI and introduced another one called Cryptographic API Next Generation, which is also the only one that is FIPS compliant if you have to deal with data, government organizations, healthcare, or anything in the United States or in many other countries. I'm going to show you the more complicated version first, which is all the declarations that you have. It's all in bcrypt. Bcrypt is the basic primitives of cryptography. And that's also encrypt, which deals with certificates and validations like these kind of things. So what we want to do in this case is using public-private key encryption. In order to have public-private key encryption, we need to have a public and a private key, obviously. So in this case, we use cryptographic next generation. We request the RSA provider, which is a public-private key encryption algorithm, and specifically we are using 384-bit prime elliptic curve Diffie-Hellman key exchange. We generate a key pair that is 2048 bits long by using generate and finalize key. Then we export these keys into variables, close everything, and return these variables as a parameter. The export key function is, because we have to do it twice, I put it into a separate function. It's exporting the key and it's determining the size, then exporting the key and, well, getting the key. We can use the key to encrypt data. So in this case, we open again the ASI provider. We import our key pair that we created, the public key in this case, in order to encrypt, which can only be decrypted using the private key. Then we encrypt data using the public key, encrypt a block. Because public-private key encryption is block-based, we can only encrypt one block at a time, and that block size is the same as the key size. So in this case, we can only encrypt 2048 bits at a time, or 256 bytes. Oops, sorry. So, and then we do some cleanup and return this. Decrypting is very similar. It's just using basically decrypt instead of encrypt. That's a very common scheme in encryption. So let's look at what this all looks like. So we have the decrypted value at the top, it's sample data, and then you see the encrypted value down here, and you see it's a block of 256 bytes. Again, this is something you need to keep in mind if you store this in a table. You cannot store a 10-character field encrypted in a 10-character field. You have to put it into a memo field. Also, the cryptographic API next generation supports hash functions. In this case, in using the _script API, we created a SHA 128 hash value, which is not secure anymore. So we are using a 256, which is still more secure today, not as secure. You probably shouldn't use it either, but it's more secure. We open the provider, and then we get the object length, we get the hash digest length, we create a hash, we hash the data, and we get back the final hash. Lots of code, all to get back, basically, to get back this value, which is, in this case, instead of 128-bit or 16-bit byte character, it's a 32-byte string. All of this is a lot simpler because now we have Fox CryptoNG, which is a open source library that I wrote some time ago. It's available on GitHub. This is the link, and this is the updated sample. You will get it after the session. All the code that I've seen so far in here is now encapsulated in one class, Fox CryptoNG. So all these things like hash, getting a hash value is just a method, and all the logic that is necessary to access the CNG API directly is in this class. I also added comments when the algorithm that I'm using isn't necessarily the most secure one, like SHA-1 and MD5 hashes are not considered to be secure at the time I wrote this, which was 2 years ago, 2.5 years ago. 256 was still secure. Yeah, you can just use this one in your application. The one thing is, if you create, that Rick Strahl found this out and actually wrote a blog post about it, is if you create this instance, every time you do something in a loop, it will always declare these API functions. Even though they are already declared, FoxPro is still loading the library. And if you do something that is not in Win32 API, but in a specific DLL, that takes a lot longer than a Windows API function. So in order to allow you to override the behavior, control the behavior, you can subclass this class and do something of the things that I suggested in this comment. So if you have a performance issue, go to this method, is basically what I'm trying to say. Instead of rewriting all the samples, let me just show you how this code looks like by using the test that I included in Fox CryptoNG. So to generate a hash value, these are the two lines you need. You create an instance of Fox CryptoNG, and then you call the hash short 256 method to get back this string. For 512, you just replace 256 with 512, and you get back a 512-bit long hash value. Generating keys is two lines. You pass in two variables by reference, and then private holds the private key and public holds the public key, and it's by default 2048 bits long. You can make it a little bit more secure because most code that is trying to break things is based on standard key length. So if you use a slightly different key length, then you have a slightly less risk of having someone break into your application because they might not check for this key length. So you can specify any key length you want. Be aware that this is an exponential function. So the higher the value, the more bits you want, the even longer it takes. So while 2K run relatively quickly, as you've seen, if you up this to 4, 8, or 16K, it takes like 256, 300, 400 times the duration. So it can run for minutes instead of for milliseconds. So you want to make sure that this matches the computer that you are using or your users are using. To encrypt data, you need the public key. You can store it somewhere. Because in this case, I'm generating it, but every time you generate a key, you get a different key. So you want to store the public key somewhere. And then you just use encrypt RSA and you get encrypted data back. And the length again is 248 bits, or in this case, 256 bytes. Decrypting happens the same. You need to have the private key, and for encrypting the public key, I encrypt data. And then I use the private key to decrypt data and make sure that's equal. We also have AES 128 hash values, encryption. So we pass this in, and for 128, AES 128, your password has to be exactly 16 bytes long, or 128 bits. Actually, the CryptoAPI uses the length of the key in order to determine if it's using 128, 256, or 512 AES, based on whether you pass in 16 bytes, 32 bytes, or 64 bytes. The way you get a fixed length string for this is by using a hash value for the password. So you have a password that could be any length. Then you create a hash value that has a fixed length and use a hash value in order to encrypt data. And the rest isn't really. MD5 is possible as well, but only use it for non-secure mechanisms or because you have historic data, because it's not secure anymore. And because you don't want to use the old API actually anymore, the _script API, I also started working on one project which is having a library that is using Fox CryptoNG instead of the old Crypto API, but it's having the same interface as _script. So far, it only implements the block cipher. Be aware that it's not only the library that is insecure, it's also the algorithm that have been chosen, like MD5, which is not secure. So even using this library is only the first step. It moves you to a new library from Microsoft, a FIPS compliant library, but it doesn't make the choices any better. You still have at some point should migrate to more modern algorithms. Any questions so far?
Yes, there are a couple of questions.
Okay.
Are the API calls and results the same between different versions of Windows?
For the CryptoAPI, no. They depend on the crypto provider, and there are two crypto providers available. One is that originally shipped with XP is the 40-bit provider because of encryption restrictions rules in the United States. It was considered to be, you were not allowed to have more than 40-bit of encryption. At some point in the late 90s, early 2000s, that was lifted, that ban, and we got the high encryption package, high encryption provider, which is using 128 bits. And then sometimes the default provider on some machines is a different one than the Microsoft provider. And in this case, the results will be different unless you configure the provider in _CryptAPI. I've had problems with some computers where as soon as we had a new Windows Server version, that we had a different provider and suddenly the encryption didn't work. Also, the old CryptoAPI is susceptible to data corruption in the user profile. So sometimes you have to delete some RSA keys in there or some keys in order to be able to encrypt and decrypt again. So it's not the most stable one. Next generation is different. It's still using provider, but it's not as variable because you have to pass the provider name explicitly, and that's not changing. So in this case, it's returning the same data on different machines, provided that you have a machine that has this provider, which depends on the Windows version. For instance, the latest ciphers have been made available in Windows 11 H2, so in the last years, a couple of months ago in the release. So if you use the latest ciphers explicitly by using the provider, then you can only decrypt it on Windows 11 H2 or Windows Server 2025, not on older systems, because the DLLs are not available.
Okay, there's another question. Can Fox Crypto NG be used in Visual Fox Pro Advanced 64-bit?
It's just calling API functions. So it's not doing the encryption itself. It's just calling the bcrypt DLL, and Windows on a 64-bit system ships with a 32-bit and a 64-bit bcrypt DLL that behaves identically. So I haven't tested it, but I don't see any reason why it shouldn't work because it's just using Windows APIs. There's no custom DLL or anything. It's just whatever Windows has. And it would be using the one from the WOW64 or the System 32-bit, System 32 folder, depending on whether you are running a 32 or 64-bit application.
Okay, that's it for questions.
Okay. Let's go back to COM. So on this machine, I do have a COM object, but it's not registered. So if I run this code, obviously the class definition is not found. I'm also, as I shouldn't be, I'm also not an administrator. So right now, if I run this application, I need this COM object. There's no way I can install it because I can't access the registry. The information that we need is actually in the VBR file, so FoxPro registers all classes in HD classes root, which is only accessible by administrators. It's the system-wide registry. There's also a user-specific registry available, which is not in HD classes root, but in current user system, now in software classes. And then we have all the same registration that we have for system-wide, but user-specific, and anything in here can be changed by the current user. So let's look at what the reg file would look like for a COM server, for this particular COM server. That's what you have if you export the registry after registering the registry into a reg file. It's using a node syntax, reg edit 4. And this program is then changing basically just the HK classes root with the HK current user software classes, the branch or the hive I've shown you before, and then creates a new file. This new file that looks like this. It's the same file, except it's not referring to HK classes anymore. It's referring to the current user. So the current user has permissions to write into this registry branch. I can register this, and if you do it using start, by using the reg file, as I do, later versions of Windows now are asking for administrative permissions. So you can't do this way on a modern system, but you can use it. You can write the keys directly because you have access to write these keys. It's just more code that you need to write. So I add this, and it's not system-wide, registered system-wide, it's just registered for the current user. So other users are not able to run this COM object, just the current user, just me. And oops. And I can now instantiate the object and call a method. Sometimes this isn't what you want. Sometimes you want things you don't want to deal with the registry. So let's unregister the component again. We verify that the component isn't registered anymore. So let's use an alternative approach. This alternative approach only works for non-visual controls. It does not work for visual controls like a tree view or anything. It just works for COM servers. So what we do is we basically implement COM, what COM is doing ourselves. Every COM DLL, and this applies only to DLLs as well. So every COM DLL that we create, that we have available, that we want to use, every COM DLL implements a function called DLL get class object, which is more or less the same as a main function in a program. It's the initial function that is being called. So we declare this not in some Windows API, but in the DLL that we want to load. And then we also use the create instance of a helper DLL. I'll show you the source code in a minute. What we need two interfaces, two COM interfaces. COM interfaces are identified by a GUID. So we use the iDispatch interface and the iClass factory interface. Initially, we pass in the class ID. And the other one thing is you cannot use the name of the object. You actually have to pass the class ID of your COM server in order to call this. So we call the DLL get class object, a function within the COM server passing the class ID, because every COM server can implement multiple different objects. We request the iClass factory interface for that object, and we get back a pointer, which is an address of the iClass factory interface instance. Then we call the create instance method, passing in the pointer for the iClass factory, and get back an iDispatch interface pointer, or 0. 0 means something didn't work. If it worked, we use Cert3096 to turn the iDispatch pointer to a FoxPro COM object and return that object. So let's quickly look at the source code. So this is the source code. We pass in the iClass factory pointer, and then we use that pointer to call the create instant method on that interface. In Foxpro, we can call interface methods on interfaces using a pointer, but only on interfaces that inherit from iDispatch. And iClass factory inherits only from iUnknown, not from iDispatch, so we cannot call it from Foxpro directly. So we need this little tiny one line of code to create the instance, which returns an iDispatch interface pointer. And then we call the release method in order to avoid having a dangling reference, return the iDispatch pointer. So this is what the call looks like. We pass in the class ID of our COM server, we pass the location of the DLL, and then we just execute the code. And you see that it's actually returned the same thing as the previous one. OX is an object. It has a method, we can call it. But at the same time, the object still isn't registered. You can achieve similar things using reg-free registration or COM by embedding a manifest in your application. But this is another way. Any questions about this?
No questions.
Okay. Protecting data. And I have to hurry up. A simple way to make sure that you have a hash value, if you don't want to use one of those like MD5 or SHA-1, is even SYS 2007, which is a CRC32, can protect data. Whenever you have data that you want to hash or do something, you always should add extra data, an extra string to the data called a salt, in order to make sure that even if somebody knows the algorithm and the data, they cannot calculate the hash value. CRC has the advantage that it produces vastly different results even for tiny changes. So it's something that as a quick and dirty solution is possible because it at least lets you check very quickly and whether two strings are identical or not. Foxpro is very vulnerable to code injection. There are tons of ways that you can change code or change data in order to execute Foxpro code within your Foxpro application in the runtime that is not intended to be run there. And if you have one line of code being executed, you can copy out all of your VCXs. You can have access to all tables. You have access to memory variables. You can just run a list memory and get the data. You can run list objects. You can change whatever you want. So basically, run one line of Foxpro code in your in the context of your application, and your application is screwed. In order to avoid this, you have to do a lot of things. And actually, I don't know any Foxpro application that is doing all of these things. But still, to give you some ideas. One is you can replace FLLs by using a different FLL that is doing something different. And if you don't check what FLL you are loading, then you would just load the FLL that has the same name and is in the path. So it might be somewhere else where the user has write permissions, like in the temp folder. And if that temp folder is in the path anyway, Foxpro would load it. So what you can do is you embed the FLL inside your application, inside the XE, and then copy it out to a temp folder using a random name and load from that place. So you don't have, the attacker doesn't have a way to replace an existing FLL. Instead, you use something that is securely embedded in your application. So this is loading the FLL and then just displaying set library and then setting it to null, and which releases the library. And we run this as an exe, and we see as that library is empty. We load the library. It's not being loaded from our application folder or from the application directly. It's loaded from temp folder, and then it's gone. Other things you want to do is you want to avoid that somebody can manipulate your DBC file, because as you can have DBC hooks that fire even before a table is being opened. So imagine you have a DBC where the user table is in there, and the DBC is manipulated, you can add users, you can delete records, you can do anything you want just by adding a hook or adding a trigger or adding a stored procedure that's being called as part of one of these things. So validate DBC is doing this. The first thing, it's checking whether the DBC is read-only, because you really do not need to change the DBC at runtime at the user side. You only do this at development time. If you create temporary views, you can use a different temporary DBC, but you don't have to change the database at the customer side, except for installing a new version. And then we use templates that we embedded as text files into the application to verify that the DBC, DCT, and DCX files are identical. So I have Northern DBC, and I have these files that would be part of my exe. And if I execute this, I get true. So the DBC on disk is still the same as the one I expect. This is much harder to do with DBF files, because DBF files have sections of the header that is different. One is the modification date, the date the table changed last time, and the other one is obviously the number of records. Every time you add a record, there's a counter in the header that's incremented. If you have an auto increment field, the value for that auto increment field is stored in the field definition. So we need to mask this out as well. So this code is creating a mask consisting of all set bits, and then we set it to 0 for the parts that we don't want to check. Next, we read the header from the table using low-level file functions and call the compare with mask function, passing in the header and the template that we have stored in our application and the masks that we just generated. Compare with mask is first checking if the data is somehow different in any way, and if not, it's applying the mask to the data from disk, the data from our application, and making sure that they're identical. Apply mask is using bitwise AND in order to basically zero out all the parts of the actual DBF and the template that we don't want to compare. So the header looks like this. The first line contains all these things that change. So we look at the one that is on the table. You see those values are different, hopefully. They will be different as soon as the application is being used and records are being added. So in order to validate, we call the validate DBF function, passing in the DBF, the path to the DBF file, as well as the header that we stored in our application. And let's do it again so that you can actually see this. So it's identical. So this DBF file hasn't been modified. Another way to get code into your application is by creating custom indexes. So what this code is doing, and I'm not going through this code, it's reading the low-level structure of the CDX file to extract the index expression and the filter condition. So this is what it looks like. We see that we have an index on upper city, and the customer ID has a for filter that says 1 equals 1. So we can use this again to check whether this is what we expect. We just, in our program, we can just check whether the first tag has the correct expression before we open the table. Because we always have to establish that it's secure to open the table before we attempt to use it. Once we use it, it would be too late. A lot of programs in Fox will also use scripts stored in a table like this one. So we have code in there, and it's some dynamic message box customized code. I've seen this a lot with customization where certain parts of the application, like templates for reports or certain layouts, are put as Foxborough code into memo field and then customized at the customer side. You don't want to execute code in there that has not been verified by you or by your application. So what this is doing, it's showing a hash value for this code. And the run code function is locating the script and then calculating the hash value based on the name, some salt, and the code. And if that doesn't match the stored hash value, then it's refuses to execute the code. And only if it's not been manipulated, it's executing. So it says hello world. If I go in here and add something like a hacked word and run code again, this time you see this script has been manipulated because it's not the one that you expect. It's something else. So let's look at combining a couple of technologies here by using a login screen. There are so many things you can do to make a login screen unusable or easy to bypass. One of the things is what we do in the load method here is whenever you press Control-0 in a Foxborough application, it's inserting null into the value property of that text box. So if you insert null into the password property, you probably get a check that is not secure. And if you do something where you use the return value and it's null, if I always execute the else branch. So if your not secure part is the if part and the secure part is the else part, and you press Control-0, you get into the application. So we disable Control-0, and we also initialize the random number generator based on the current time for Foxborough, because we use random values and we don't want to have the same sequence every time. When we call the login method, we do a random number of checks before we fail and sleep for a certain time, in this case 3 seconds. We make it random because that makes it harder to automate this. You also notice that this code is not saying if this check password, but it's saying this check password and then this if this LOK. Because if you manage, in this method, you manage to get an error handler on the return statement, for instance, by bypassing the line that created the variable that is being returned, and you choose ignore in the error handler and ignore the return statement, you get the default return value, which is true for all methods in Foxborough. So by bypassing or by causing an error intentionally on the return statement of the check password method, you would force it to return true, even though the user might not be able or might not be valid to log in. So we actually set a property and then we check this property to avoid this. A check password is also doing the same thing as we did before. We check whether this can be valid at all. Empty or null is not valid. We verify that the user table has not been manipulated. We verify that it only has an index tag on username and nothing else, no filter, no other tag. And when we calculate the hash value, because we don't store the password, we just store a hash value. And when we seek the value, we do this with the exact length of the field. And we only accept results that have exactly one record where the ID is larger than 0, where the ID is not empty. If you get 2 records back, this can't be right. One of the 2 might be right, but you don't know which one, so it's not You just don't let it happen. And at the end, you close the table because you don't want some other code be able to access the user table. So this user table does not have a password. It has a hash value as a username. And if I log in, just as you would expect, I get a true. If I typed in a different password, I would get a false. Okay, we ran out of time. Privileges, we skip that. We switch back to PowerPoint. And I will answer any questions any further questions in the Q&A session. Just for post-quantum cryptography, I wrote that I will be presenting something about post-quantum cryptography based on the announcement of Microsoft in September 2024. They added ML-KEM, formerly Kyber, and in December even MLDSA, formerly dilithium, to the encrypt library, which is the core library of Windows used by all Windows mechanisms, including the TLS stack, including Azure, including cryptographic libraries. They also announced that cryptographic support for the next generation CNG API is coming in the coming month. And the latest I checked was 2 weeks ago. I checked the new Windows SDK, and there's still no trace of that. So I don't have any sample for that because it's not yet supported. But as soon as it is supported, I will add it to whatever session I'm presenting on security next. So what you learned today, if you have problems in your code with security, please, 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 please fix them. And other than that, thank you very much for listening, attending the conference. Thank you very much. And yeah, hope you have an enjoyable conference.